Hey guys, I hope you're having a good night. The first thing I want to cover real quickly is how to do the portion on the top of your log practice properties right here where they give you some approximations and then you have to use those approximations and the properties in order to find these logs. So let's go ahead and take a look at some examples. So first of all, let me show you how to use your calculator to get these logs. So the log button is right here next to the 1. So you'd press Control and 10 to the X. And so if I wanted to do this first log base 5 of 3, we would put a 5 in here and we would put a 3 in here and press Enter. And so this log is going to be approximately, let's go with 4 decimal places, 6826. Okay, and the next one, log base 5 of 4. Okay, that's going to be 861, and I'm going to go ahead and round that to 4. And one more. Log base 5 of 20. And this one's going to be 1.8614 approximately. Okay, so let's say real simple problem. We want to find log base 5. Notice the bases have to be the same of say 12. So we would look at these arguments up here and figure out what combination, multiplying or dividing, would get us a 12. Well, 3 times 4 is 12. So we would be using this property right here. So we would break that 12 into 3 times 4. So this would be log base 5 of 3 times 4. Whoops, I don't know where I got that from. And then using this property right here, we're going to split it up. We're going to expand it into addition. So log base 5 of 3, first argument, plus log base 5 of 4. And we know what log base 5 of 3 is. It's approximately 0.6826 plus log base 5 of 4. And adding those two up, it's going to be approximately 1.544. Now that's an approximate answer there. So if I was to check my answer here, log base 5 of 12, we get approximately 1.544, which is what we got right here. Okay, so please do not just plug these into the calculator. Use the approximations that are given here, okay, and use the properties to figure out the answer. So let's look at another example. Here we multiply. So why don't we do one where we have to divide? So let's do log base 5 of, let's do this one, 20 divided by 4 is 5. Interesting. Log base 5 of 5. Okay, so log base 5, and we'll take this argument divided by this argument, which will be 20 over 4. And then we'll split it up this time. Since we made it into a division problem, we'll subtract the two logs. So we're going to take the log of the u value, subtract the log of the v value to get our answer. So this was 1.8614 minus 0.8614, and our answer is 1. Checking our answer. Log base 5 of 5, 1. Okay, so there's a heads up on how to do those problems. Now you can when you do a multiply, you can do more than more than 2 to get this number. So for example, let's say we had 27, log base 5 of 27. Well, that would be 3 times 3 times 3. Okay, and since we're multiplying in here, we would add the individual logs. So the log base 5 of 3 plus log base 5 of 3 plus log base 5 of 3. 1 for each of the numbers. So then we would take 0.6826 plus 0.6826 plus 0.6826 in order to get our answer. So this is the kind of work I want to see on this paper. If you just put down the answer, then either you cheated or you used your calculator to get the answer. Only use your calculator to check to make sure you did it right. Okay? So another thing I want to tell you all about logarithms is that the argument can never be negative. So sometimes when you're doing logs, you're going to end up with a quadratic. So for example, let me think of a quadratic here where you get a positive and a negative number. X plus 5, x minus 3. So that would have a solution of negative 5 and positive 3. So let's say we have log, and we'll do base 10 of x plus 5 plus log of x minus 3 equals I changed the problem. I decided that this would be an easier problem to follow. So write this down and know it. The argument, remember the argument is this value right here, x and 64, cannot be negative. Okay, so if I was solving this equation here, I would use a property of logarithms where when we have a number out front, okay, you can move it up on top of the argument like this. So I'm going to move the 2 up on the x. Now in the directions it says to remove the logs. The algebraic step for removing the logs is actually raising both sides to base b. So these bases will cancel out. So we end up with x squared equals 64. And then subtract the 64. You could take the square root of both sides right now, but I'm going to go ahead and do it this way. And we have a difference of 2 squares, so that breaks down to x plus 8 and x minus 8. So we have solutions of x equals negative 8 and x equals 8. So now when you plug it back in, the 8 goes in just fine. If you square the 8, you get 64. So that's a good answer. But here, remember the argument cannot be negative. So this is an extraneous solution. Extraneous. So we cross it out. So this is the solution. So whenever you get solutions, you need to really plug them back in and make sure your argument does not turn out to be negative. Because if it does, then you have an extraneous solution and you cross it off. If both of them happen to make negative arguments anywhere in the problem, then there's no solution. Okay? All right. Let's take a look at an equation really quick here. Let's say we have log base 7, and here is our long argument. So what you need to look at here, oops, base 7, sorry about that, is we have subtraction. So you look at your properties, and you know the subtraction, we divide the arguments. Right here on your video notes, subtraction, so we divide. So we're going to condense 2 logs down to 1. So these 2 logs condense down to 1 log, and we have a division problem now. Okay, to cancel our 2 logs, they're both base 7, so we're going to raise both of them to base 7 to cancel those out. So we end up with 10x minus 12 over 2 equals x. If I divide both of these by 2, I get 5x minus 6. Subtract the x, add the 6. So we get 4x equals 6. Divide by 4. X equals 3/2. Take that, plug it back in, and 10 times 3/2 is going to be 30/2, which is 15. 15 minus 12 is 3. So that works. 3 divided by 2 equals our answer, which is 3/2. All right, I'll see you guys in class. Thanks for watching.